Good morning. This is the Friday, May 8th, final Zoom for statics and strengths of material. It's also VE Day, Victory in Europe during World War II, a little bit of history. I promise I won't throw that on the final. Starting out with the final exam for statics and strengths is this coming Tuesday, May 12th. We're going to start at 6 p.m. instead of 7. We'll give you that 4-hour window. And again, the final exam, Tuesday, May 12th, starting at 6 p.m. I will send out an email probably Monday morning regarding the details. It is comprehensive, so it's the whole semester. And we'll go over a couple of helpful hints after I talk a little bit about the final lab experiments. We've just basically run out of time. So we're just going to do a little bit of an overview of the lab experiments that that we have done in the past. Can you see Vanco Hall?
Yes.
Okay, good. I didn't know if anybody was awake out there. I might have put you to sleep already. That would have been my record. So hopefully you got some coffee. And in the week of 4 May to 10 May, under lab experiments, I gave you the actual PowerPoint because there's some videos embedded in that PowerPoint. And I figured that way you can take a look at some of the cool videos, some not so cool. And so, again, you've got I gave you this one. You've already done that work. You've already done the deflection. I don't know, did I accidentally get rid of frozen concrete? I did. I'll redo this this PowerPoint for you. So yours will not include the ground freezing, which I was hoping to include. I must have missed that. So let me, since this is my master, we'll put it right there. So again, it will start with shear, glued and doweled. Then we went to deflection calcs. Then we went to ground freezing. And what we were going to do in the lab was to talk about a catastrophe, 13 fatalities, 13 deaths, if you will, in Chicago in 2003. And a 3-story deck was installed, I believe, without a building permit. And they had a big party up on this 3rd floor, and it failed. I believe it was the combination of many things, but one of the factors was the attachment of the ledger beam back to the old brick building. And then it literally just pancaked and killed 13 people. So we looked at it and we said, well, what can we simulate in terms of a structural experiment for a ledger beam? So we took, we had the freshmen make some brick mock-ups using live mortar, and we lagged it in with the masonry screws. And then what we had to do is, you can imagine that this is the ledger beam, say, for the deck. Well, we had to put on a mirrored ledger beam, if you will, so that we could load it. We took this big steel plate and then we loaded it to see what type of failure we would have. And there's an overall view of it right there. And then this one, you can see where the mortar joint failed because we did 2 things. We lagged it into we lagged those screws using a hammer drill. We lagged those screws into the mortar joint. We also lagged them into the brick units themselves in the hollow core. And the one picture I don't have is where we lagged them into the web, if you will, of the brick. So for the mortar joint failure, it literally just tore out of the mortar joint. It did not shear the fastener. Here, it did shear the fastener. So we could get the total load that the old Roman universal testing machine would record. And then we just made a very simple calcs. We said, you know, if we had 3 fasteners on this side, 3 on the other side, we'll call that 6 fasteners. We took a digital micrometer, got the diameter, calculated the cross-sectional area of the masonry screws, and looked at what the actual load at failure was on those screws. And then you can go into the manufacturer's data and see what the safe load would be, say in pull-out, almost like a tension pull-out, or a shear. Okay, and then you can kind of compare that to what the load value was at failure. So that's one. You students actually made the mock-up, or you did all the fastening, whereas again the freshmen would build the masonry for us, and we let that cure for a month. Then we thought, well, you know, we thought, well, what did we think? There we go. So we thought, well, we could also test as if we are anchoring not into brick, but we were anchoring into say a concrete wall, much like my own, where the fasteners rusted because I forgot to go back and put in an expansion bolt. So we used expansion bolts here, anywhere from a 1/4 inch. One year we used 1/2 inch. And again, we anchored it. We used an old flexure beam. We put a flexure beam underneath it. You know, that way we had some leeway in case it really started to work down the base material. Okay, and you know, we tried different expansion bolts. Sometimes they call them molly bolts. There's different types. The ones we had were a friction fit, if you will. What I'd like to get into is some of the adhesive anchors, where you drill the hole, you put in an adhesive, like a two-part, I'm drawing a blank, epoxy, if you will. Set the bolt, and then wait till it cures, the cure time, and then go ahead and fail it as well. Now the mistake I made here was that we put the fastener too close to the top of the concrete, and that was interesting. So you can tell that the anchor bolt is trying to pull out. We did not shear it, but it actually broke because there was not enough distance, what they call concrete coverage, from the insertion of the bolt to the top of the concrete. So again, those were some pretty interesting tests that we did. And we show you this just to remind you that building codes are mainly for safety. And terrible tragedy. So that was one of the tests that we did. And then we got into some column analysis, buckling, calculate L over D ratios, critical and actual failure loads. This will be on the final. This could be on the final. We could give you a total load, give you the total number of fasteners. You know, and then just ask you to calculate the stress on each fastener. Or we could give you the allowable stress and ask you to calculate the allowable load, right? A equals B over C. Stress equals load over area. It's the meaning of life. A equals B over C, and drinking enough water. So again, just very basic calcs are on the final, and tons of units. Tons of units. You got to know your units. Those of you who are going on to structural theory, I always tell the statics folks a couple of weeks before we start in August, God willing and the creek don't rise, as the old saying goes. Hopefully everybody will do well over the summer. But I would say start studying those units a couple of weeks before. You'd be amazed at how good your grades are going to be in structural theory. And that is a sincere hint. So we go back to here. We're going to give you the length of a column. We're going to give you, say, it might be a 2x4. So the L over D ratio, the D is always the least dimension because that will be the axis that is the weakest, and that'll be the axis about which the column will buckle. Okay? So you want to study those and study that example that I gave you on Tuesday. Bolted connections, right? Bolted connections. You can listen to this one. This is a video. I don't think you can hear my. Can you hear the computer?
No.
No.
Good, because I put some YouTube. You're going to hear a word I shouldn't have used. It's not terrible, but it's not great. But you can take a look at this. So this is in double shear, right? So that's where they sheared right off. So again, make sure that you read the whole problem in the final. Is it single shear or is it double shear? Double shear means you have double the available resisting area. So you can watch that video. And then once you watch it, get on. Am I taping? Yes. Once you watch it, make sure you watch these two because that ties in with some of the language that I used. Then we've got some, did it again. We've got some welded connections. So the question there is, did the weld break or did the base material, the parent material that we are welding together, the two pieces, or did that fail? Or was it a combination of the two? Okay. And that ties into a little bit of, where did I put it? Chapter, what chapter is that? Chapter 10, structural connections. So if you flip through chapter 10, just go through it. It's very basic. And they get into failure of bolted connections starting on page 497. They talk about shear failure. We talked about that. Okay, we didn't talk much about bearing failure. This gives a really good description. They don't give enough photographs, but they give some good 3D views. And so the bearing failure involves the connecting members and not the bolt itself. Okay. Tensile failure. Okay. It kind of tears, if you will, of the plate across the bolt holes. So these are any test questions that we give you. If it's something like this, like a tensile failure, that's, you know, this experiment or this stress right here, stress equals load over area. You've seen that the whole semesters. So that we wouldn't give you. If it were something like this, which is something that you haven't seen, we will give you the formula. So make sure you look at the formula and make sure, say on the column analysis, that all your units are consistent. That's the key. Okay, make sure the units are consistent. Okay, so there's an end tear rupture, again with a bearing failure. Design stresses for bolts just gives a really good, you'll get into a lot of this in structural theory. So if you don't sell this book back, it is helpful, especially chapter 4, which is the load trace. I probably said that a million times. And again, we used to go through some example problems. This is just way too, you know, again, we're just going to go basic. Load equals allowable shear stress times the area. Because if you took the area, whoops, I think I got them in there. If you take the area, put it over here, then it's allowable stress equals load over area. So again, very basic test questions. Okay. And then they get into, there's some more beam connections, welded connections. So this starts on page 519. We probably will throw in a couple of very basic weld questions. We could say that a weld can handle so many pounds or kips per linear inch of weld. So again, a lot of it comes back to A equals B over C. I got to take a look at the waiting room. I thought I let them in. Alrighty then, they should be okay. So this gives some good, good basic nomenclature. I like that word. The lingo of welding. And Mr. H in structural theory gets into this a lot more than we do. And that actually was in, I thought I had it, yeah, welded connections. So we actually broke welded connections. I thought I had better videos on that, and I didn't. Again, wasn't allowed to go back into Smith Hall. Oops, that's bitterness. Don't tell anybody I said that. So we'll get back to this. Types of welded joints, okay? So again, just to give you a good, some good basics. And that's where YouTube comes in really handy. You can really learn a lot about this. Welded joints, the symbols. Some of you may have seen that in commercial construction, okay? The types, the parts of a fillet weld. Okay, so take a, the throat, the toe, stuff like that on page 523. So just very basic calcs in chapter 10 of the textbook. There might even be a, let me see, there might even be in Vanco, let's go up to the JN, let's see, there might even be in the JN notes connections. Did I put them in? No, so I will put in JN connections on Vanco. JN did a nice job on connections, which is what we're talking about here. So that kind of, oh, and then we did a stress strain test. We literally put it's what they call a 505 specimen. Its diameter is machined to 0.505 inches. And then we put it under load, and this dial indicator, this digital dial indicator, will give us elongation up to actually 0.010 of an inch. And we compare the elongation to the load, and then the stress strain diagram will allow us to get the modulus of elasticity in the elastic zone of the material. The elastic zone is that zone where if we took the load off, the elongation or the specimen will go back to its original length. You get into the plastic zone, then there will be permanent deformation or elongation. And then the one that we just, number one, we ran out of bowling balls. We had about 30. We broke a bowling ball one year. This might have been the first one that we ever broke. So is that cool or what? So let's share the computer sound for this one. And let's play this one. Wait for it. Nice. Now, full disclosure, we would put the students outside so that they were safe. So just keep that in mind. And I was behind the console cowering, so I didn't get hit. But you all were outside, still looking in through the window so you could see it. So these other two, they take a little longer to break, but you can get on Vanco and go to 1 minute 45. You'll see this one, kaboom. This one, 1 minute 20 seconds. And that was the hands-on that we did. Again, tying in the math with the actual experiments. A lot of fun. A lot of fun. Do me a favor, if you see any experiments throughout your travels, especially you mechatronics folks, keep me in mind. Send me the information. We'll incorporate it into this course. So that was kind of a wrap up of the experiments. The final, again, is Tuesday, this coming Tuesday, May 12th at 6 p.m. And lots of units, lots of true false, lots of matching on units, lots of basic manipulation of units, right? Similar to the units quiz. Oh, that reminds me, the units quiz is open till 11:59 p.m. tonight. That's units quiz number 13, open till 11:59 p.m. tonight. And I may throw out another units quiz right around the final. I may try to do it before the final. We'll see. It would be good practice. So know your units. Because it is a comprehensive final, the 3 force systems that we learned about right in the first 2 to 3 weeks will be on the final, where we had one force and we would resolve that one force into an equivalent vertical and horizontal force components using some right angle trig. The second case that we had, that was the first case. The second case of the forces. If we had 2 forces acting at a common point and they had an acute angle between them, right? Then you had to do the parallelogram rule or tip to tail rule and use the law of cosines or the law of sines to calculate that, okay? Or it could have an obtuse angle between the 2 forces. So in other words, we had 2 forces. Now we're going to calculate for the one resultant force that gives the same effect as those 2. And then the third case was we had 3 forces acting, all meeting at a common point. And you had to extend the line of action of 2 of the forces, offset the third force, and create your force triangle. And then we would ask you to calculate one of the forces or one of the angles. So know how to do those 3 forces. Reactions, always look for symmetry. Some have symmetry, some do not. Okay. Compression, tension, shear calculations, moments. Again, you have to calculate, moments. You got to analyze shear moment diagrams. That was a big part of the last test. We're going to throw more problems on that. Framing problems, framing plans. Get familiar with that. Tributary widths, and so on. Okay. And then we had some connection calculations. So again, it's a comprehensive final and very fair. And, it really is. And geez, that's about all I got. So I only did about a half hour, but like I said, this is our last Zoom. Do you have any questions?
Yes.
And what is it?
Is it going to be a 2-hour window, or is it going to be the full 4 hours to do it?
Probably the 4. Probably the 4. Every once in a while you get somebody who shows up with a half hour left. If you do that, you got a half hour to do the test because it does close right at 11. Actually 10, it'll close at 10. If it starts at 6, it'll close at 10. So the other thing is the directions that I'll give you on Monday, you will be able to, when you look at the test problem, you can zoom in and out the test problem so that you can see the entire thing, so that the part of the Vanco grading, it almost looks like, well, it looks like all of the test questions, little blocks, sometimes cloud the test questions. So you can zoom in and out. And I'm going to give you directions on that when I send you out the info on Monday. So make sure that you have a good computer. I don't know, maybe some of you take the test on the phone. You'll still be able to zoom in and out. So, any other questions?
Will we know our grade after the 4 hours?
I think you will. I think the grades are viewable at 4 hours. And I'm glad you brought that up. There's another thing that we're going to do is remind you, for God's sakes, make sure that you submit your test answers. I think they ask you at least 2 times to submit a final submission, if you will, so that you have completed the test. That's critical. So just be really, really picky at, and really diligent so that you know that you have submitted done your final submission on the test. I'm not a big fan of online tests, but it is what it is. So we'll just make the best of a bad situation. And as I've said, I hope all is well with you folks. And then what I'm going to do is it's going to take me a couple of days. I've still got a little bit of grading to do on the one load trace that was the last lab when we were all together. And then I will probably email a kind of like a final grade that is based on 800 numbers that is scrambled. So it won't be 1 through 62 or 62 down to 1. It'll be scrambled so you won't know, hey, number 32 got a 77 average, if you will. I got to post grades by Monday, May 18th at 11:59 p.m. Sound familiar? But I hope to have them done a lot earlier. A lot earlier. So, any questions? Any other questions? So just study those units. Go over the units quizzes that we gave when you were in person. Retake them. And just, I think page 2 of the units handout. Remember that 30-page units handout? Probably one of the greatest handouts that we've ever given you. Mr. H did 90% of it. I added a little bit. Mr. V added some. Especially if you're doing structural theory. Man, that thing is, that's an encyclopedia. So you can, those first few pages really give you a feel for the units. And dimensional analysis, converting from, say, cubic feet to cubic yards. Very, very helpful when you study. So, well, any last questions? I guess this will end our Zoom for this semester. It's actually gone fairly smooth. I appreciate your patience. I wish you all the best for this summer. Some of you are graduating. I definitely wish you all the best. Keep posted as to how you're doing. And I hope to see you in the fall. That's my biggest hope. So take care, everybody. I'm going to stop recording right now.